Hi everyone, this is Dr. V.S. Nishuk from EC Department, SNS College of Technology. Here we are going to see the topic DC machines. So this is the outline of this video. It starts with need of DC machines and its construction and basic working principle and real world applications. Initially, the electrical machines are classified based on the AC and DC supply. So whichever machines with the DC supply is called as a DC machines. So this is further classified as DC generators and DC motors. Here these generators and motors are both useful in variable speed control and reversible operations. So especially the DC motors are used for traction control and lab testing equipments and rolling mills, battery vehicles, etc. And coming to the DC generators, it is used in communication equipment, electroplating and welding application. Next, coming to the basic construction of the DC machine. Here we are having different parts like yoke, field system, armature core and commutator, brushes, shaft. So if you see yoke, so it is the outermost part of the machine, so which acts as the shield. This is a not moving part, stator part. And coming to the field system, it consists of poles and field coils, etc. So which is mainly used for production of magnetic field. And coming to the armature core and winding, it is mainly used in the EMF induces. So the EMF induces because of this armature core and winding. And then commutator, which is used to make the current induced, that is EMF induced, to reach further for different terminals. So that is the use of the commutator. And coming to the brushes, so it connects to collect current from commutator. And shaft. Shaft provides mechanical coupling for rotation. And coming to the working principle, so if we see the generator, so it is based on the Faraday's law. So here in the magnetic field, if we are keeping any conductor nearby, it starts to produce an EMF, electromotive force. So that is said by the Faraday's law. So which is given by the equation E equal to K into phi into N, where phi is nothing but the flux and N is nothing but the speed. Similarly, for motor action, so we are following the Lorentz law, so which is said about the how the electrical energy is converted into the mechanical energy. So with the equation force F equal to BIL, B represents the magnetic flux and I represents the current flowing through the conductor and L represents the length of the conductor. So here is the diagrams represents the generator action and motor action. So the motor action represents the Fleming's left hand rule and the generator represents the Fleming's right hand rule. So coming to the DC motor prototype and generator prototype. Here in this prototype we have taken both motor and generator and how it is utilized to provide an electrical application. So here we have given an input from DC and then we are giving that input to the motor, so which creates the mechanical energy from electrical input. So that is given to the generator part, and in generator part this mechanical energy is further converted into electrical energy, which can be analyzed with voltmeter and ammeter, and its final output is provided in the lamp, glowing of the lamp. So this is the prototype we have shown as an example. So here we are using both the DC machines, generator and the motor. So coming to the real world applications. So here these DC machines are utilized in laboratories, transportation purposes, industrial purposes, educational purposes and automation purposes. So here some examples are given as electric trains, trams, and traction control unit, and then rolling machine, conveyors, cranes, blowers, and then we can use in drones and robotics, etc. So at the result, we are going to summarize the topic DC machines. So here in this video, we have discussed the need of DC machines and the construction, what are the main parts, and then we have seen about the Faraday's law and Lorentz law, and then we have concluded with the prototype and its application. So this is the time for assessment. A major advantage of a DC machine is variable and reversible speed control. And then that is the right answer. In a DC motor, the direction of force can be determined using Lenz's law. And here is the reference books and reference sites for this DC machines. Okay, so I hope everyone can understand the topic with this video. Thank you all for joining this video. We can join in the next video.